Okay, Math 9s, welcome back. In this video, we will be matching equations and graphs. Okay, our focus will be to use points to match equations with their graphs. And we're also going to match equations with their graphs with the slope-intercept form of a line. So just a couple of comments before we get going here. A few different forms of a line that we'll see. One of them is the slope-intercept form. We'll cover this in a little bit more detail down here. There are some other forms of a line. They are, and you see these more in Math 10, they are the standard form, the general form, and the point slope form. Okay, so all of these different forms can be used to talk about the same line. Okay, so just a little bit more about the slope-intercept form of a line. This information, if you're looking for a good resource to go and check out, you can check out Math is Fun. Equation of a line takes you to this, and it gives you a good overview of, hey, general equation is y equals mx plus b. We'll write that down in just a minute, and we'll just go through what some of these things mean. This is just a good resource to go and check out. Okay, just to summarize what that website says, our slope-intercept form of a line looks like y is equal to mx plus b, where x, y are coordinate points, just short form coordinate and points. M is your slope, which is your rise divided by your run, and then b is the y intercept. It's where your line will cross the y-axis. Okay, so we'll keep this in mind. I'm going to put a little highlighter around that general form, okay, because we see that over and over again as we go through math courses in high school. Okay, so if we scroll down to example number 1 here, which of these three equations is the match for the relation graphed? How do you know? Okay, so our focus here is to use points to match equations with their graph. So I'm going to pick a point on this graph, and I'm just going to try it in each of these equations. Okay, so I'm going to look at the point 1, 6. So x is 1 and y is 6. And I'm pretty much just going to see or ask, hey, do they work? Does that point work in each equation? So in this first one, we have y is equal to 3 minus x. Well, the y has to be 6. And I'm going to put a question mark above the equal sign because I'm asking the question, hey, if I put the point 1, 6 in where x and y are, does this point work in this equation? So putting 1 in for x and 6 in for y, I'm just doing a little bit of math here, and we get to the end here and we say, hey, 6 does not equal 2. This is definitely not, or sorry, that point 1, 6 is not on the line of 3 minus x. Okay. So if we try that same point for the second line here, y is 6 and x is 1. So again, we're asking the question, I'm going to put a little question mark above the equal sign. We're asking the question, hey, does the left side equal the right side? Well, this right side is now 3 times 1, which is 3, minus 3 is 0. Does 6 equal 0? No, 1, 6 is not on this line. Okay, finally, we'll check this last one where we're putting again 6 in for y, 1 in for x. And then we do with a little question mark above the equal sign, we're asking the question, hey, does 6 equal, this right side is going to be 3 times 1 plus 3 is 6. Yes, 1, 6 is on that line. Okay, so another way, I'm going to go back and just answer this question. Which of the three equations is the match for the relation graph? How do you know? We can say that number 3, call this number 3. Equation 3 is the match, and we know that because the point 1, 6 is on that graph, and it works in that equation. Okay, so now what I'm going to do is I'm going to go and rewrite this equation, this third equation that we know is the equation of this line. I'm going to write down that equation, and what I'm going to do is I'm going to turn this number in front of the x, which is our slope. I'm going to put that as a fraction of 3 over 1. Okay, so we haven't changed the number 3 by putting it over 1. Okay, and the reason that I'm doing that is because our general form, our slope-intercept form, for the equation of a line is y is equal to mx plus b. So m is our slope, and in this case, it's going to be 3 over 1. M is this number in front of the x, and then our y-intercept, our b value, is 3. So if I were asked to quickly graph this line, I know what the y-intercept is 3, so I'm going to go up, and you can find, hey, there is the point 0, 3, that is our y-intercept. Now, to go from one point to another, I can use the slope value, and the slope is 3 over 1. Slope is rise over run. So if I go up 3, 1, 2, 3, this is going to be my rise, and if I run 1, my run is how far I go in the horizontal direction. So if I pick another point down here, let's pick this point down here. So going between any 2 points, we can go up 3, there's 1, 2, 3, and then over 1. Oh, there's another point. I can do the same thing. Up 3 and over 1. So that's how that slope number is, how that looks on a graph. Okay. Hopefully that's not too confusing. We'll flip over to the back side and look at one other example here. Okay, backside example number 2, we're asked which graph is the match for the equation 2x minus 3y is equal to 6. So for each, and then how do you know? For each one of these graphs, I'm going to pick a point. I'm going to pick a point, and I'm just going to check that it's on the line. Okay, so sorry, let's start with this first one. This first point that we can try is 0 and negative 2. So if I try that point in the equation 2x minus 3y equals 6, I put 0 in for x, minus 3 times y, which is negative 2. We're asking the question, hey, does that equal 6? This entire thing is 0. Negative 3 times negative 2 is 6. Does that equal 6? You bet. So we're asking, does 6 equal 6? Yes. Okay, so next one we can look at is, I don't know, let's just choose a point here. Let's choose 0, 3. In the second one, and we can go through this exercise of going, okay, well, 2 times x minus 3y, so 2x is 2 times 0 minus 3y, y is 3. Does that equal 6? 2 times 0 is 0. Negative 3 times 3 is negative 9. Does that equal 6? No way. No way. Okay, so this is definitely not the graph that fits the equation that's given. Okay. Lastly, maybe we'll do an x-intercept this time. I'm choosing intercept values because intercept values always have a 0 in them. Either the x or the y is 0, so that makes it a little bit easier for us when working an equation because one thing is always going to disappear. Here we have, so the point negative 3, 0 is the one that we'll try. So that means 2x, it becomes 2 times negative 3 minus 3y. Y is 0, and then does that equal 6? Question mark on top of there. So this whole thing goes away. 2 times negative 3 is negative 6. Does that equal 6? No way. This one, that point does not work for the equation that's given. Okay. Okay, so I'm going to go back and just to confirm for us with this first graph that we're looking at on the left, I'm just going to pick another point. Let's pick another point. Maybe we'll pick some negative values here. We'll pick this point down here, which is negative 6 and negative 6. And I'm going to put those values in just to prove to myself that, yeah, okay, if that in fact is our equation, then that point should also work. Okay, so 2 times our x value, so 2 times negative 6, minus 3 times our y value, negative 6, that should equal 6. We'll put a little question mark up here. And now let's do some math. So 2 times negative 6 is negative 12. Negative 3 times negative 6 is positive 18. Does that equal positive 6? Negative 12 plus 18 is positive 6. Does that equal 6? Yes. Okay, so both of these points, we know that both of these points, they definitely work on this graph. So anyways, it's just another confirmation to know that we have that we've chosen the right graph for the equation that was given. Okay, so if we just scroll down a little bit, just a couple of final thoughts. So any point that works in the equation, will be on the line. Okay, and so any point that is on the line will work in the equation, has to. Okay, the big idea from this section is to match equations with graphs. Okay. Okay. Hope that gets you going with that section. Thanks for watching, and we'll see you soon.